All right, so today we're really diving deep into the world of Zig. This isn't just another one of those new programming languages everyone's talking
It's
about.
got people talking.
From what I'm seeing, this could be a serious contender to see.
Yeah, especially for systems programming, there's a lot of buzz right now, especially for people who really know what C is all about, what it's good at. And also, I guess you could say it's quirks.
Yeah, definitely. And the articles I've been reading, it seems like Zig wants to be this refined version of C, but then also go in a new direction.
Yeah.
It's tough to do both, right?
It is. It's a delicate balance, but I think Zig actually does it really elegantly. It's almost like, imagine you take the power of C and all that control that you have, but then you add these modern safeguards on top of it. Like one example, manual memory management is still there, which a lot of people, will be familiar with and see. But then Zig introduces this thing called optional types, and it basically acts as a safety net against null pointer errors.
Ah, okay, so fewer crashes.
Exactly. That's always a good thing. Right.
Always a good thing. So then how does Zig compare to Rust?
Oh, good question. Because Rust is kind of the darling of the systems programming world right now.
Yeah. Everyone's raving about its memory safety and all that.
Yeah, and there are just different approaches to safety. Rust is very much like, you can think of it like the overly cautious parent that's like, here are all the rules, you must follow these, you're going to be completely safe.
Okay.
Whereas Zig is more like, here's how to be responsible, I trust you, you're not going to burn the house down, right?
Right.
You have a little bit more freedom.
Okay, so it's that trade-off.
Exactly, more control, potentially faster because of that, but it also means you need to know what you're doing.
Okay. But in terms of like practicality, I mean, can Zig work with existing C code? Because, I mean, rewriting everything from scratch is...
No, nobody
What?
wants to do that,
Oh,
right?
no.
That's actually one of Zig's biggest strengths, I think, is that you have this seamless C interoperability. So you can call C code directly from Zig. You can use your favorite trusted C libraries. You can really think of it as being bilingual, but in the programming world.
Okay, so that's a huge time saver.
Huge,
Wow.
especially when you think about modernizing legacy systems.
So there was this phrase that came up while I was reading, and I had to ask about it. Something called, and I think I'm saying this right, compile time magic.
Compile time magic. It's a great way to put it.
Is it magic?
Kind of, yeah. Comp time, that's what we call it in Zig. And it's one of its most powerful features, I think. It's almost like, imagine if you could run your code during the compilation process. Yeah, like you have this mini program that's optimizing your code before it even runs.
So it's getting a head start before the program even launches.
Exactly. And what this means is that you get these, you can get some really nice performance gains, especially for anything that can be pre-computed.
Okay, so that's wild. So you're talking about faster code, but without even, you don't have to do anything.
Yeah, well, you have to do a little bit.
Okay, I'm sold.
Yeah.
But this all sounds very, very system level. Is it only good for building the guts of an operating system or something?
It's really good at that.
Or can you use it for other stuff too?
Not at all. So it's fantastic for systems programming, but this comp time thing we were talking about and just its raw speed make it really versatile. And this comp time thing, we should dig into that a bit more because it's really cool how much it can do.
Yeah, let's unpack that a little bit. So what are we talking about with comp time?
So one of the really fascinating things about comp time is that you can actually use it to generate code during compilation.
Wait, what?
It's pretty meta. It's like you can write Zig code that writes more Zig code for you,
Hold on.
but it happens before your program runs.
So it's so you're writing code, that's writing code.
Yeah. It's wild, right?
Amazing.
It's like giving your code a team of assistants, and they do all this work for you up front.
Okay,
And this has some crazy implications.
I bet.
One of them is you can actually use this to generate these highly optimized data structures.
So,
But these data structures are specifically tailored to your program's needs. It's like having custom-built tools.
oh, okay, so it's not just generic data structures. These are very specific. It's bespoke.
Exactly. Bespoke data structures that are perfectly designed for what you need.
So you're squeezing every ounce of performance.
Yes. Wow. That's really what it's all about, is making your code as fast as possible. But honestly, that's just scratching the surface with comp time.
There's more.
You can use it for other things too, like code generation or metaprogramming, where you're writing code that can manipulate other code.
So it's like giving superpowers to your code. That's crazy.
It's really powerful stuff.
That sounds incredibly complicated, though. Is this something that the average programmer can even wrap their head around?
Yeah, that's a great question. And it gets to like one of the core principles of Zig, I think, is that they really tried to make it approachable.
No.
So while it's very powerful, they've really gone to great lengths to make comp time as intuitive and easy to use as possible. You don't need to be like a meta programming guru to benefit from it.
So it's powerful, but it's not scary.
Yeah, exactly.
Okay, good, good, good. So do you have any like specific examples of how this is actually being used in real life?
Yeah.
Because this is all very theoretical, and I kind of need something to like really bring it home for me.
Oh, yeah, absolutely. So one really compelling example is in the game development world, because game developers are always trying to squeeze every bit of performance.
Oh yeah, of course. Frame rates and all that.
Exactly. Imagine you're building a game with these complex 3D graphics. You could actually use comp time to analyze your game's levels and then pre-compute stuff like lighting and shadows.
Wait, so you wouldn't even do that while the game is running?
Exactly. It's already done.
That's
So
incredible.
instead of like your computer struggling to render all that in real time, it's already baked in. We use that term baking.
Wow, baking it in at comp time.
Yeah,
Yeah,
exactly.
okay.
So it's a massive performance boost.
Okay, so this isn't just some theoretical thing.
No, no, no.
It's actually being used in game development to...
It's being used today by real game developers.
Okay, wow. This comp time thing has really opened my eyes to like what Zig can do. Because it's not just, a better C or a faster C. It's like a whole different beast.
It's a different way of thinking about programming.
Yeah, it really is. So another thing that's, I guess you could say, generating a lot of buzz is how Zig handle errors. And this is something that I think every programmer struggles with. You get those cryptic error messages.
Oh, tell me about it. Oh, yeah.
Yeah.
Traditional error handling can be a nightmare, with those exceptions and cryptic messages. It's the worst.
Yeah, for sure.
But Zig actually takes a very different approach. Instead of exceptions, they have these things called error types.
Error types.
Yeah, so instead of your program like throwing its hands up in the air and crashing,
Right.
it'll actually tell you what went wrong.
Oh, so it's more like informative?
Exactly. It's like
Yeah.
having this like built-in troubleshooting guide. So you can actually handle those errors directly in your code. You're not relying on some like catch-all mechanism.
Okay, so you can actually pinpoint the issue.
Exactly. And this makes your code much more robust and it makes it more predictable, which is really important when you're talking about, systems programming where an error can be catastrophic.
Right, right. Of course.
Yeah.
So you really need that reliability.
Yeah.
Okay, let's switch gears a bit and talk about cross-compiling. So for people who don't know, we're talking about the ability to write your code once and then run it on all these different platforms, like different operating systems,
Yeah.
different devices even. What makes Zig good at this?
So what's really cool about Zig is that cross-compiling is like baked into the language itself.
Oh, really?
Yeah.
So it's not just like an afterthought.
It's not something you have to like cobble together afterwards. It's not some complex configuration nightmare. It's very simple to do. You just tell Zig which target you want to build for,
That's it.
and it takes care of the rest.
Wow. So no more like fighting with different tool chains and things like that?
Exactly. It's very streamlined.
Okay.
And this makes it really appealing for, for developers who need to run their code on a bunch of different devices.
Right.
Whether it's for embedded systems or, even something like WebAssembly to run in a web browser, Zig can handle it all.
So it could be a tiny little microcontroller or a huge server.
Exactly.
Wow, that's pretty impressive. Are there any downsides to Zig?
I mean, every language has its trade-offs, right?
Right, of course.
I would say Zig is still relatively young compared to like, these behemoths like Java and C-Way.
So it doesn't have like as big of an ecosystem, right?
Yeah. Yeah.
Tutor libraries and
The
things.
community is growing super fast. I mean, really passionate people. New tools and libraries are popping up all the time. But yeah, if you need something that's got like a massive ecosystem with solutions for everything already built,
Right.
it might not be there yet.
So it's kind of like moving to a cool new city, but, it's still under construction a little bit.
It's a great way to put it. But for some people, that's part of the appeal, right? They like to get in early.
Yeah, be on the cutting edge.
Help shape the direction of the language.
So then, where does Zig really excel in the real world?
So obviously, we've been talking about systems programming, and that's a perfect fit for Zig, right? You have this fine-grained control over memory. The performance is very predictable. There's no garbage collector to worry about. So you can build things like, operating systems and embedded software, really high-performance applications. Like you're building something from the ground up, and you have all the tools you need.
You have complete control.
Exactly. And when you add in that easy cross-compiling, it just makes it like a dream for that kind of work.
Write once, run anywhere, as they say.
Exactly. And then you've got game development, which we've touched on a little bit.
It's just so different.
It's a different world, yeah. But Zig is also gaining a lot of traction there because game developers, they also really need performance.
Of course.
And they need that fine-grained control, and Zig gives them that.
It's like fine-tuning an engine. You can get everything perfectly how you want it.
Exactly, yeah. And Zig lets you interact directly with hardware.
Okay.
And there's this growing ecosystem of, game development libraries. So if you're a game developer and you really want to like push the limits of what's possible, Zig is a really compelling choice right now.
So it sounds like Zig is great for games, but it's not just about like operating systems and video games, right? What about just regular programming?
Yeah. You can absolutely use it for that. I mean, it's really good at that performance-heavy stuff.
Right.
But, Zig's actually very versatile. It's got this clean syntax. It's all about predictability. And you can easily use it with all those existing C libraries that are out there. So you can use it for, like, anything, really. Command line tools, little scripts, even web services.
So it's like having this like all-purpose tool in your toolbox.
Yeah, exactly.
You might use it for the heavy-duty stuff sometimes.
Right.
But it can also handle those everyday tasks.
Totally. And honestly, I think one of the best things about Zig is that it kind of like makes you think differently about how you write code.
Really?
Yeah, it kind of challenges those old ways of doing things,
That's interesting.
Gives you this fresh perspective on things.
So it's not just about learning a new language. It's like learning a new way of thinking.
Exactly. You got it.
Okay, so for someone listening who's like, all right, I'm interested. How do I get started with this Zig thing? What do they do?
Well, the good news is that Zig's got really good documentation.
Okay.
And the community is super friendly, very welcoming to new people. The best place to start is probably the Zig website itself. They've got everything you need. There's a full language reference, interactive tutorials. They even have this cool playground where you can just like try out Zig code right there in your browser.
Oh, that's nice. So you don't even have to install anything to kind of like get your feet wet.
Exactly. And if you're more of a hands-on learner, just jump into a project. There's tons of open source stuff on GitHub that use Zig.
Oh, cool.
Yeah, it's a great way to like learn from others, see how it's used in the real world, maybe even contribute something.
Yeah. Get your hands dirty.
Exactly.
Awesome. Awesome. So I guess taking a step back for a second, we've talked about all the technical stuff, and it seems like Zig is gaining popularity, but what about the future? Like, what's exciting about Zig? What could it change?
What really excites me about Zig is that it could be this bridge between, that old, reliable world of C and all these new languages that are coming out.
Okay.
Because C, it's the foundation for so much stuff.
Yeah, it's everywhere.
But it can be a little intimidating to work with, especially if you're used to, like, the safety nets that you get with more modern languages.
Oh, right, all the memory management. And
Yeah.
it's easy to make mistakes.
Exactly. And that's where I think Zig really shines because it's like this like gentler introduction
Oh,
to that world of systems programming.
makes it less scary.
Exactly. You get that more modern syntax, you have good error handling, all those nice safety features for memory.
Okay, so Zig's like the intermediary then between these two worlds.
Exactly. It's the best of both worlds, really, because even for those C veterans, they can, experiment with these new ideas without having to completely jump ship.
It's like building a bridge between two islands
I love that.
so they can share like knowledge back and forth.
Yes, that's exactly it. It's not about replacing one with the other.
Okay.
It's about giving more options to developers.
Right, because each language has its like strengths and weaknesses.
Exactly.
It's good to have that variety.
Absolutely.
Well, I think that's a great place to wrap up our deep dive into the world of Zig. It's definitely an exciting time to be a programmer, and with everything Zig has to offer, well, who knows what the future holds,
The
right?
possibilities are endless.
Yeah. So for everyone listening, if you're curious, go check it out, dive into the documentation, play around with it, join the community, and maybe you'll build the next big thing with Zig. Until next time, happy coding, everyone.